So now we have this counter circuit basically working, and we're going to connect it to the MyDAQ. So I'm not going to be using a push button anymore. I'm going to use signals from the MyDAQ to drive the clock. So first thing, make sure you disconnect the USB cable, power down the MyDAQ, and let's take it one step at a time. The first thing we're going to do is get rid of that push button that was over here and make a connection from the analog output into the Schmitt trigger inverter. So first, the other connection, is also this analog ground has to be connected. We already have digital ground connected, but we're going to connect analog ground to the ground connection on the circuit. So this is the analog ground pin. It's actually a couple of connection points. Either one of them works. Both of these go to the same place. So I'm going to pull the push button out. I don't need that anymore. And the capacitor and the resistor. Now I need to make a jumper to go from analog output channel 0 to this pin 1. So I don't have any jumpers that are long enough, so I'm going to make a jumper by stripping the end off of this. Get an idea about how long it needs to be. Okay, about that long. Strip the other end, and okay, now I've just connected analog output channel 0 to the input. The next thing I'm going to do is connect the reset pin. Oh, actually, I'll do the AND gate first, the start stop. So that's the AND gate pin, which at this point is right here. It's tied up to 5 volts, and I'm going to pull that out and replace that with a jumper over to digital output 0. So I'm going to have to make another jumper. And so the last one is the reset, which currently is connected to ground, but we're going to tie it over to digital output 1. So we're going to take that connection off, reset, and make another jumper. Okay, so I should be ready to test this with the MyDAQ.
So now we have the counter circuit hooked up to the MyDAQ, and we're going to turn the MyDAQ instruments on. We're going to turn on the function generator to generate a clock, and we turn on the digital writer to generate the start, stop, and the reset controls. So first of all, we need to plug in the MyDAQ. And then when the instruments and apps comes up, so we're going to bring up the function generator. So double click function generator. And when it comes up, it's defaulting to a sine wave. So we want to change that to a square wave. We also need to change it to a digital square wave, which goes from 0 volts to 5 volts and back to 0. So the volts peak to peak have to be changed to 5, and the offset has to be changed to 2.5. And we're also going to set the function generator for a very low frequency. So I'm just going to put 1 hertz, that's 1 pulse per second. That way we'll be able to see the counter counting. Now we bring up the digital writer, and so I'm going to hit run on the function generator, Now you can see I'm getting a pulse from the function generator through the inverter, but the AND gate input, one of the AND gate inputs is 0, so it's not allowing the pulse to go through the AND gate. When you have one input of an AND gate at 0, the output is at 0 regardless of the other input. So I'm going to turn on the digital writer. And click the start stop. Now you can see the clock is going through the AND gate to the input of the counter, and we have a binary counting sequence. So it'll just keep counting like that. And if I speed up the frequency, it's going to count faster. And if I go fast enough, you're going to hardly be able to see it. Let me go back to 1 hertz. So let me stop the count. And you notice how it's stuck at, well, it happens to be stuck at 15. So now the next input, number 1, is the reset. So if I put that, switch that to logic high, it resets back to 0. Okay, I'm going to do something else. I'm going to connect the 4 binary outputs to the MyDAQ digital pins 4 through 7. So I'm going to start with 7 because that's the most significant bit. I'm going to connect this one to digital output 6, this one to digital output 5, and this one to digital output 4. And what this is going to do is it's going to show the binary values on the MyDAQ digital reader. So let's see if I can get these so we can see all 3 of these. So we've got the function generator, the digital writer, and the digital reader. And notice the digital reader is already set to read lines 4 to 7. So I don't have to do anything else with that. I'm going to turn it on. And now we're going to turn the start stop on. And now you can see the binary sequence also appearing on the MyDAQ digital reader. Okay, and we can crank up the frequency if we want to. All right, and then if I stop the count at any point, freezes the number. What that does is stops the clock. And then if I want to reset it back to 0, I just click the reset pin. All right, so that's the basic digital counter working with the MyDAQ. Good luck with the lab.